So good morning students and welcome to the lecture on multivariable calculus differentiation. In this lecture we shall study about the differentiability of multivariable function or total derivative of multivariable functions and homogeneous functions. Alright. So let us define what is the differentiability or total derivative of a multivariable function first. Suppose that we are given a function z equals to fx, y. So we are given a function of two variables. Z is the function of x and y. And suppose the first order partial derivative of this function z equals to fx, y are defined through an open region R containing the point x naught comma y naught, and that fx and fy are continuous at x0 y0. Right? It means जो हमारे पास में फंक्शन गिवन है z equals to fx, y, उसके partial derivatives first order के exist करते हैं and the partial derivatives are continuous also at the point x naught comma y naught. Then the change in the value of the function, it means आपके पास में ये कोई point surface है, ये यहाँ पे ये point आपके पास में suppose x naught comma y naught, and suppose this is our another point whose coordinates are given by x naught plus delta x comma y naught plus delta y. So value of the function at this point is given by z equals to function of x naught comma y naught, and value of the function at this point is given as z equals to function of x naught plus delta x comma y naught plus delta y, right? So these are the two values of the function at two distinct points. First point is x naught comma y naught, and second point is x naught plus delta x comma y naught plus delta y. Now the difference between the values of the function at these 2 points is given by this one, f of x naught plus delta x comma y naught plus delta y. This is the value of the function at this point, and minus f of x naught comma y naught, this is the value of the function at this point. And suppose this difference is denoted by delta z, right? Now with the help of the Taylor's theorem, right? Now if we apply the Taylor's theorem for the two variables, so here we have applied the theorem of Taylor's theorem for two variables, right? So if we apply this theorem, Taylor's theorem for two variables, then expansion of this term is given as fx at x naught comma y naught multiplied by del x plus fy at x naught comma y naught multiplied by delta y plus epsilon 1 delta x plus epsilon 2 delta y. So we have considered only the first order terms in the Taylor series or Taylor's theorem, right? So after applying this Taylor's theorem and simplification, we get delta z equals to this equation, all right, where epsilon 1 and epsilon 2 are the function of this difference delta x and delta y. So epsilon 1 is the function of delta x delta y, and epsilon 2 is the function of delta x delta y. Now these epsilon 1 and epsilon 2 approaches to 0 as delta x and delta y approaches to 0. So you can see from here, if delta x and delta y approaches to 0, it means this point approaches to this point. This is our suppose point Q, and this is our point P. If delta x and delta y are approaches to 0, it means this point Q approaches to point P, right? So in this case, this difference total delta z is, in this case, this can be written as dz equals to fx dx plus fy dy. All right. If this condition hold, delta x delta y approaches to 0, in that case epsilon 1 and epsilon 2 approaches to 0. So you can say that dz equals to fx dx plus fy dy. So now this one is known as the total derivative. All right. This is our total derivative. This is our total derivative of the function z equals to fxy at the point x naught comma y naught, right? Here fx and fy are the partial derivatives of first order, at the point x naught comma y naught, right? And if this condition hold, then we can say that our function is differentiable at the point x naught comma y naught, right? So what is the definition of the differentiability of the function? It means if your function is given by z equals to fx, z equals to function of xy, then we can say that our function z equals to fxy is differentiable at the point x naught comma y naught if the first order partial derivatives are exist at the point x naught comma y naught and are continuous also at that point. Then we can say that our function is differentiable at the point x naught comma y naught, right? तो जब भी आपके पास में कोई प्रॉब्लम आती है, prove that your function is differentiable or not. So for this one we need to find the first that our function given function has partial derivatives of first order or not. So first of all we find the partial derivatives of first order with respect to the independent variables. All right. Then we check the continuity of these partial derivatives. If the function consists first order partial derivatives as continuous at the point x naught comma y naught, then we can say that our function is differentiable at the point x naught comma y naught, and it is defined as dz equals to fx dx plus fy dy, where fx and fy are the partial derivatives at the point x naught comma y naught. So this is our definition of the differentiability for two variable function. Similarly, we can extend this definition for the three variable or more than three variables, right? So what is the definition of the differentiability? Your function z equals to fxy is said to be differentiable at the point x naught comma y naught if the given function has first order partial derivative with respect to the independent variables, and also these partial derivatives are continuous at the point x naught comma y naught. Then we can say that our function is differentiable at that point x naught comma y naught. So these are some important remarks here. Existence of the partial derivatives fx and fy. Here fx means this denotes delta f del x, and this fy means del f upon del of y. Existence of fx and fy at the point x naught comma y naught is the necessary condition for differentiability. All right. So keep this thing in mind that existence of the partial derivatives is the necessary condition for the differentiability of the given function z equals to fxy. This is not a sufficient condition that if your function has a partial derivative, then you can't say that your function is differentiable or not. So existence of partial derivatives is only the necessary condition. Now, what is the sufficient condition for the differentiability? This is stated by this theorem. If the partial derivatives fx and fy of a function fxy are continuous, if the partial derivatives fx and fy are continuous throughout an open region R, then we say that our function f is differentiable at every point of R. So this is our sufficient condition to prove that your given function is differentiable or not. So for this one, we need to find that first of all, your given function has partial derivatives fx and fy, and these partial derivatives are continuous throughout the open region R. Then we can say that our function is differentiable in the given region R at every point of R, right? So this is our sufficient condition to find or to check whether our given function is differentiable or not. So this is very important theorem to prove whether your given function is differentiable or not. So note down this definition. And this is also trivial result. If a given function fxy is differentiable at the point x naught comma y naught, then f is continuous at x naught comma y naught. You know, this is also true for one variable case also. If you remember, in case of one variable, if y equals to fx is your given function, f is differentiable, then you can say that f is continuous also. F is continuous also. but converse may not be true. All right. If your function is differentiable in case of one variable, then it must be continuous also. But if your function is continuous, then it is not necessary that your function is differentiable in case of one variable. Similarly, this is also valid for the two variable or more than two variables. If your function fxy is differentiable at the point x0, y0, then your function is continuous at the point x0, y0. So again, note down this definition. Let us see the example based on differentiability. So that the given function fxy equals to x square minus y square upon x minus y at the point 1 minus 1, and it is 0 for xy equals to 1 minus 1. We need to show that the given function is differentiable at the point 1, minus 1. So if you remember, what is the condition to prove whether your function is differentiable or not? We need to apply this definition. What is the definition? First of all, we need to find the partial derivatives fx and fy of the given function fxy, and then we check whether our partial derivatives are continuous or not at that particular point, if we talk about the point only. So this is our sufficient condition. So first of all, we find the partial derivatives of given function fx and fy. These are the partial derivative. And what is the point? 1, minus 1. So we need to check whether our given partial derivative 1 and minus 1. So we need to check these partial derivatives are continuous or not. If these partial derivatives exist and continuous, all right, then we can say that our function is differentiable. All right. So first of all, we find the partial derivatives at the point 1, minus 1. And if you remember, by the definition of the partial derivative with respect to x, what is the definition? Partial derivative of x at the point x, y is given as limit h approaches to 0, f of x plus h, y minus f of x, y upon h. This is our definition for the partial derivative with respect to x at the point x, y. Now, if we apply this definition here at the point 1, minus 1, then our definition will be limit h approaches to 0, x is replaced by 1 and y is replaced by minus 1. So it becomes f of 1 plus h minus 1 minus f1 minus 1 divided by h. Now, for the given function, what is the function? X square minus y square upon x minus y. So just replace x by 1 plus h and y by minus 1 in this function. Then, and after simplification, we get this relation, right? 1 plus h square minus 1 divided by h upon 1 plus h plus 1. Now, if we apply the limit h approaches to 0, after simplification, we get limit of this term is equals to 1. So what is that partial derivative here? So our partial derivative fx at the point 1, minus 1 is plus 1. It means partial derivative is exist at the point 1, minus 1. Similarly, we can find partial derivative fy at the point 1, minus 1, and which is defined as limit k approaches to 0, f of 1 minus 1 plus k minus f of 1 minus 1 divided by k. If we apply the x equals to 1 and y equals to minus 1 plus k in given function, and after simplification, we get that limit of this is equals to plus 1. So again, you can see that the partial derivative at the point 1, minus 1 is plus 1. So from here, you can see that partial derivatives are exist. So it means partial derivatives exist at the point 1 comma minus 1. Now next we check whether these partial derivatives are continuous or not. So if you remember what is the definition of the continuity, you can see your function is continuous at the point, suppose a comma b. This function is continuous at the point a comma b if the limit of this is equals to value of the function at this point. So this is our definition of the continuity. If this condition holds, then we can say that our function is continuous at the point a comma b. Now our function is a partial derivative here, fx and fy. So what is the condition of continuity here for this one? Limit xy approaches to 1 comma minus 1, fx is equals to value of the partial derivative at the point 1 comma minus 1. If this condition holds, then we can say that our partial derivative fx is continuous at the point 1 comma minus 1. And similarly, you can check whether your partial derivative fi is continuous or not. So now next we find fx, because we know the value of partial derivative at the point 1 comma minus 1, which is equals to plus 1. Now we need to find this left hand part now, right? So we need to find this left hand part. For this one, we need to find the value of fx. What is the value of fx here? Because we are given only fx here. So first of all, we find fx from the given relation. So from here, fx means partial derivative of f with respect to x. So now if you differentiate this term with respect to x, taking y as a constant, all right? So what should be the value? If you apply the denominator rule, so after simplification, so this is x minus y 2x minus x square minus y square plus 1 divided by x minus 1 square. So if we simplify, then we get x minus y square divided by x minus, this is x minus y square, right? If you differentiate this relation with respect to x, taking y as a constant, we get x minus 1 square divided by x minus y square, right? So this is our partial derivative at xy not equals to 1 minus 1. And we know that fx at 1 comma minus 1 is plus 1 here. We have already found out, which is plus 1. So you can see that fx at the point x comma y is x minus y square divided by x minus y square for xy not equals to 1 comma minus 1. And value of the partial derivative fx at the point xy, it means, what is the point xy? It means 1 comma minus 1. It is plus 1, right? Now next we find the limit xy approaches to 1 comma minus 1 of fxy. It means we need to find the limit of this one at the point 1 comma minus 1. And if you remember, how do we find the limit of the given multivariable function? So with the application of the previous lectures, the limit of this function fx at the point 1 comma minus 1 is 1, which is equals to the value of the function fx at the point 1 comma minus 1. Now this condition shows that partial derivative fx is continuous, right? So this implies that the partial derivative fx is continuous at the point 1 comma minus 1, right? So first part is clear now. Your first order partial derivative fx is continuous at the point 1 comma minus 1. Similarly, we need to check whether our partial derivative fy is continuous at 1 comma minus 1. If your partial derivative fy is continuous at the point 1 comma minus 1, then you can say that your function f is differentiable, right? So next we check whether our function fy is continuous or not. So if you apply the same definition as we did in case of fx, you can easily verify that the partial derivative fy at the point 1, -1 exists and continuous. So hence you can say that our function fxy is differentiable. All right. So to prove that our function is differential, we have applied the sufficient condition. इसको प्रूव करने के लिए हमने कौन सी कंडीशन अप्लाई की है? ये वाली कंडीशन अप्लाई की है. If the partial derivatives fx and fy are continuous at the given point xy, then we can say that our function is differentiable. So जब भी आपको कोई प्रॉब्लम मिले कि check whether your given function is differentiable or not. So first of all, find the value of the partial derivative at the given point, and also check whether your partial derivatives are continuous or not at the given point. If both the conditions are satisfied, then you can say your function is differentiable at the given point. और इनमें से यदि एक भी condition satisfy नहीं होती है, then you can say that your function is not differentiable at the given point. So remember this definition here. So let us recall what we have done in the previous slide. The existence of partial derivatives fx and fy at the point xy is necessary condition for the differentiability of fxy at the point P. The function may not differentiable at a point P even if the partial derivatives exist at the point P. It means आपका फंक्शन जरूरी नहीं है कि डिफरेंशिएबल हो जबकि उसके पार्शियल डेरिवेटिव एग्जिस्ट करते हैं. Partial derivatives की existence does not imply the differentiability of the given function. If partial derivatives are continuous, then you can say that your function is differentiable. So only existence of partial derivative does not imply the differentiability of the given function. If partial derivatives are continuous, then you can say that your function is differentiable. So next example is based on this important remark here. So the given function fx equals to x cube plus 2y cube divided by x square plus y square for xy not equals to 0, 0, and it is 0 for xy equals to 0, 0. The given function is continuous at the point 0, 0. Also possesses the partial derivatives fx and fy at the point 0, 0, but it is not differentiable at the point 0, 0. So you can easily verify that your given function is continuous. आपका फंक्शन में न्यूमरेटर की डिग्री कितनी है? 3 है, डिनोमिनेटर की डिग्री 2 है. आप लिमिट किस पॉइंट पे निकाल रहे हैं? 0, 0 पे. सो जब भी आप 0, 0 पे आप लिमिट निकालते हैं, आपके डिनोमिनेटर की डिग्री न्यूमरेटर की डिग्री से कम होती है, देन इन दैट केस यू कैन से दैट योर फंक्शन इज कंटिन्यूअस at the point 0, 0. So you can easily verify that given function is continuous. Also you can find partial derivatives fx and fy at the point 0, 0. Easily find out कर सकते हैं. What is the definition of the partial derivative? So you can easily find the partial derivative at the point 0, 0. So partial derivative at the point 0, 0 means limit h approaches to 0, f of h, 0 minus f of 0, 0 divided by h. If we put x equals to h and y equals to 0 here, so f of h, 0 would be h cube upon h square minus f 0, 0 means 0 divided by h. So partial derivative is 1. Similarly, fy at 0, 0 is limit k approaches to 0, f of 0, k minus f of 0, 0 divided by k. If you put x equals to 0 and y equals to k here, then it becomes 2k cube divided by k square minus 0 by k. So this is 2. So you can see that partial derivatives fx and fy are exist at the point 0, 0. But you can easily verify that these partial derivatives are not continuous at the point 0, 0. It means next part is fx and fy are not continuous at 0, 0. We need to prove this one. To prove that given function is not differentiable. So partial derivatives are exist, but these partial derivatives are not continuous at this point 0, 0. Because if you calculate the partial derivatives, so if you take the partial derivative with respect to x, right? If you differentiate this function with respect to x, then fx equals to, if you simplify, then your partial derivative with respect to x is will be x की power 4. If you simplify this one, x की power 4 plus 3x square y square minus 4xy cube upon x square plus y square की power 2. 4xy not equals to 0, 0. So this is our partial derivative at the point xy not equals to 0, 0. Now if you find the limit of this function fx at the point, if you find the limit of this function xy at the point 0, 0, you will see that the limit of this function does not exist. Does not exist. Why? Because if you take here y equals to mx as a path, यदि आप यहाँ पे y equals to mx path लेंगे, then if you put the value of y equals to mx here, then it becomes m1 plus 3m square plus minus 4m cube divided by 1 plus m square whole square. If you put y equals to mx here and simplify, then we get 1 plus 3m square minus 4m cube divided by 1 plus m square. Now it means your limit of the function depends on slope of the line y equals to mx. If m equals to 0, then limit will be 1. If m equals to 2, then limit will be different from previous one. So you can say that your limit of the given function fx depends on the path. And you know that if your limit of the function depends on the path, then you can say that your limit of the function does not exist. Because if limit of the function exists, it is path independent, right? So you can easily verify here that limit of this function fx at the point 0, 0 does not exist because it depends on the path. If you take y equals to x path, then limit will be different. If you take y equals to 2x, then limit will be different. All right. So you can easily verify this one. Similarly, you can prove for the second partial derivative of fy at the point 0, 0 that your partial derivative of fy is not continuous, right? So you can see that partial derivatives are not continuous. So that's why your function is not differentiable at the point 0, 0. Right? So this is all about the partial derivatives, right? Partial derivative and total derivative. तो जब भी आपके पास में कोई प्रॉब्लम आती है कि प्रूव योर फंक्शन इज डिफरेंशिएबल और नॉट, तो आपको क्या चेक करना है? उसके पार्शियल डेरिवेटिव्स फाइंड आउट करने हैं उस पॉइंट के ऊपर, और उस पॉइंट के ऊपर पार्शियल डेरिवेटिव्स की कंटिन्यूटी चेक करनी है. यदि आपके पार्शियल डेरिवेटिव्स कंटिन्यूअस है और उस पॉइंट के ऊपर एग्जिस्ट करते हैं, then you can say your function is differentiable at that point, right? So you can now easily prove the problems mentioned in the assignments. Right? Now next topic is our homogeneous function. Now next topic is homogeneous function. A function f(x,y) is said to be homogeneous of degree n in x and y if it can be written in any one of the following form. If your given function can be written in any one of the following form, then you can say that your function is homogeneous of degree n. If you write x is replaced by lambda x and y is replaced by lambda y in the given function, and after simplification your function can be written as lambda ki power n fxy, then you can say that our function is homogeneous. Similarly, if you take maximum power of x in the given function fxy, then your function can be written as x ki power n. G is any function of y upon x. Similarly, if you can write your function fxy as y ki power n g of x upon y, right? So in any one of the following form, if you can write your function, then you can say that your function is homogeneous. Homogeneous in other words, आप क्या कह सकते हैं कि हमारे जो फंक्शन है उसकी ईच टर्म की यदि डिग्री सेम आती है, जो भी आपका कोई फंक्शन डिफाइन है उसकी यदि आपकी ईच टर्म की डिग्री सेम आती है, then you can say that your function is homogeneous. For example, fxy, this is our given function, and suppose this is x square plus 2xy plus y square. So now you can see that this function is homogeneous of degree 2. Why it is degree 2? Because first term is of degree 2, second term is again degree of 2, and third term is again degree of 2. Right? So if you put here x equals to lambda x and y equals to lambda y, then your function will be of in this form. It means your function will be lambda square times x square plus 2xy plus y square. Right? If you put x equals to lambda x and y equals to lambda y here. Also, you can write this function in this form also. Take the maximum power of x here. So maximum power is x square. So if you take the common x square common, then you can write your function as x square times 1 plus 2 times y upon x plus y square upon x square. It means if you compare with this one, so our g is the function of y upon x. So this is our g of y upon x. Similarly, you can write this function in this form also. Take the maximum power of y here. So maximum power is y square. So if you take y square common here, so you can write it as y square times x square upon y square plus 2x upon y plus 1. So this is our function of x upon y, right? And you can see that degree of each term is 0 here, right? X square upon y square इसको यदि आप simplify करते हैं, then degree will be 0 because numerator की degree 2 है, denominator की degree 2 है. So cancel out. So degree is 0. Similarly, this is degree of 0 and this is degree of 0. Because if you remember, constant is the function of degree 0. Right? So if your function is homogeneous, then you can write your function in any one of these following forms. Right? और in simple language, आपका फंक्शन यदि होमोजीनियस है उसका मतलब क्या है? ईच टर्म की डिग्री आपकी सेम होनी चाहिए. यदि फर्स्ट टर्म सेकंड डिग्री है तो उसके ऑनवर्ड जो भी आपकी टर्म्स मिल रही है वो भी सेकंड डिग्री होंगी. और यदि ऐसा नहीं होता, then you can say your function is not homogeneous. For example, x square plus y square plus xy cube. Now this function is not homogeneous. This is not homogeneous. Why? Because first term is of degree 2, second term is of degree 2, but our third term is of degree 4. which is different from earlier terms, right? So that's why this function is not homogeneous, or in mathematical form, if you cannot write this function in any one of these following form. यदि आप इस फंक्शन को इसमें किसी भी फॉर्म में एक्सप्रेस नहीं कर पाएंगे, बिकॉज दिस फंक्शन इज नॉट होमोजीनियस. You can express your homogeneous function in any one of these following form. यदि आपका फंक्शन होमोजीनियस है तो इनमें से किसी भी फॉर्म में आप उसको कन्वर्ट कर सकते हैं. बट यदि आपका फंक्शन होमोजीनियस नहीं है, then you cannot express your function in any one of the following form. So keep this thing in mind. If your function is homogeneous, you can express your function in any one of the following form. Or in simple language, homogeneous means degree of each term is same. और जो भी डिग्री आएगी, that is the degree of the given homogeneous function, right? So this is our example, which is homogeneous function of degree 2, because degree of each term is 2 here, right? So let us see some more examples. fxy equals to x square plus y xy. You can see that degree of each term is same. This is of degree 2, this is of degree 2. So that's why you can say that your given function is homogeneous function of degree 2. And you can also express this function in this form. So take x square common. So you will get x square 1 plus y upon x. So, right? So this is our homogeneous function of degree 2. Similarly, 1 upon 1 plus x, 1 upon x plus y. This is again homogeneous function, because you can express this function as x की power -1 divided by 1 upon 1 plus y upon x. This is our second, this gy upon x. So degree is -1. So this function 1 upon x plus y is homogeneous function of degree -1, right? Similarly, tan inverse y upon x and square root of x upon x square plus y square plus z square are also homogeneous functions of degree 0 and -12. Because tan inverse y upon x की यदि आप सीरीज एक्सपांशन करते हैं तो उसमें आपकी जो टर्म्स मिलेगी y upon x की फॉर्म में मिलेगी. एंड यू नो दैट डिग्री ऑफ y upon x इज 0. y upon x की डिग्री 0 होगी, y स्क्वायर अपॉन x स्क्वायर होगा, उसकी भी डिग्री 0 होगी, राइट? न्यूमरेटर और डिनोमिनेटर की यदि आपकी डिग्री सेम आ जाती है तो ओवरऑल जो फंक्शन है उसकी डिग्री आपकी कितनी बनेगी? 0 बनेगी, राइट? So that's why tan inverse y upon x is homogeneous function of degree 0. If you simplify this function, take x common, तो आपका यहाँ पे बनेगा x की पावर -12 1 upon square root of 1 plus y square upon x square plus z square upon x square. So you can see that your function is homogeneous function of degree -12, right? So this is our homogeneous function. Similarly, this function x square plus y upon x plus y square is not homogeneous function. Why it is not homogeneous? Because न्यूमरेटर की डिग्री आपके पास में डिफरेंट है. फर्स्ट टर्म की 2 है, सेकंड टर्म की 1 है. सिमिलरली डिनोमिनेटर में फर्स्ट टर्म की डिग्री 1 है, सेकंड टर्म की डिग्री 2 है. So it means you cannot express this function in any one of these form. इनमें से किसी भी फॉर्म में आप इसको एक्सप्रेस नहीं कर पा रहे हैं, और इसमें ईच टर्म की डिग्री आपकी सेम नहीं है. That's why you can say that your function is not homogeneous here, right? So you can easily verify whether your given function is homogeneous or not. और simple language में homogeneous का मतलब है degree of each term is same in each term. Let us see the theorem, very important theorem based on homogeneous functions. So this is very important theorem here, and the name of the theorem is Euler's theorem, right? So this is our Euler's theorem. If fxy is a homogeneous function of degree n in x and y and has continuous first and second order partial derivatives, then the value of this left hand side x times del f upon del of x plus y times del f upon del of y equals to nf. So keep this thing in mind. If your given function is a homogeneous function of degree n in the variable x and y, and suppose your partial derivatives are continuous, then the value of this left hand side x times del f upon del of x plus y times del f upon del y is equals to nf, where n is the degree of the homogeneous function, degree of the given function of the function right, degree of the given function. जो भी आपका फंक्शन है उसकी डिग्री क्या होगी, दैट इज डिनोट बाय n. Similarly, you can also find the value of this left hand term, x square times del 2f upon del of x square plus 2 times del xy del 2f upon del x del y plus y square del 2f upon del of y square is equals to n into n minus 1 times f. Alright, so जब भी आपके पास में कोई प्रॉब्लम आए, find the value of this left hand part. So check whether your given function is homogeneous or not. If your function is homogeneous, then you can apply this Euler's theorem. All right. So Euler's theorem is applicable only for the homogeneous functions. So जब आपको इस टाइप का रिलेशन की वैल्यू निकालनी है, so apply this Euler's theorem. So value of this term is equals to nf. And if you are interested to find the partial derivatives, multiply by some variables. Second order partial derivatives are सभी के सभी. So value of this left hand part is equals to n into n minus 1 times f, where n is the degree of the given function. Right. So with the help of the Euler theorem, you can easily find the value of the partial derivatives, these relation left hand parts. All right. So remember the statement of the theorem as well as these conditions also. So this is very important theorem again to find the relations given by left hand parts. Right. तो जब भी आपको यूलर थ्योरम अप्लाई करनी है, check whether your given function is homogeneous or not. So let us see the example based on this theorem. Suppose this is our given function. If u equals to x square tan inverse y upon x minus y square tan inverse x upon y for xy greater than 0, then find the value of this term. Now, if you remember that tan inverse y upon x is the homogeneous function of degree 0. This is again degree 0. So this product x square times tan inverse y upon x is of degree 2. And this is again, this product is again a function of degree 2. So you can see that each term in the given function is homogeneous and is of degree 2. So you can see that u is the homogeneous function. U is homogeneous function and of degree 2. So what is the value of n here? N equals to 2. So now if you remember the statement of the Euler's theorem, what is the statement? X square times del 2f upon del of x square plus 2xy del 2f upon del of del x del y plus y square del 2f upon del of y square equals to n into n minus 1 times f. All right. So by the application of this Euler's theorem, value of this term equals to n into n minus 1 times u here. And what is the value of n here? 2. So what is the value? 2 into 2 minus 1 times u. So answer will be 2u, where u is given by this relation. Right. So you can easily find the value of such type of relation with the help of the Euler's theorem for the given homogeneous functions. Not need to find the partial derivatives of second order here. यदि आपको Euler theorem का स्टेटमेंट पता है, so directly आप इसकी वैल्यू निकाल सकते हैं with the help of the Euler's theorem. But यदि आपको स्टेटमेंट पता नहीं है, then in that case आप लोग क्या करेंगे? You pupils will find the value of the partial derivatives of second order. आप ये वैल्यूज आप निकालने चले जाएंगे आप इसमें, और वो आपके लिए टाइम कंज्यूमिंग हो जाएगा ना. So better way, check whether your given function is homogeneous or not, and then apply Euler's theorem. So answer will be one line answer only. So you can easily apply the Euler's theorem for the homogeneous function. Let us see the one more example, which is based on application. Suppose this is our given function. U is the function of xy, which is defined as cos inverse x plus y divided by square root of x plus square root of y for xy greater than 0 and less than 1. Then prove that the value of this left hand part is equals to minus 1 upon 2 times cot of u. So let us redefine our given function. इस फंक्शन को आप क्या लिख सकते हैं? Cos of u equals to x plus y divided by square root of x plus square root of y. So rewrite the given function as cos of u equals to x plus y divided by root of x plus root of y. Now you can easily see that न्यूमरेटर की डिग्री आपके पास में 1 है एंड डिनोमिनेटर की डिग्री आपके पास में स्क्वायर रूट ऑफ 1/2 है, राइट? So you can easily see that your given function is homogeneous now, and you can express this function in this form. You can express this function fxy equals to x की power n some function of y upon x. Because if your function is homogeneous, then you can express your function in this form. So now if you take the highest power in the numerator, which is x, and denominator में क्या है? Square root of x है. So x times 1 plus y upon x divided by square root of x 1 plus square root of y upon x. So after simplification we get square root of x times 1 plus y upon x divided by 1 plus square root of y upon x. So this is our g of y upon x. Because इसमें आपकी टर्म्स किसकी फॉर्म मिल रही है? y upon x की फॉर्म में मिल रही है. डिग्री आपकी कुछ भी हो सकती है, इंटीजर भी हो सकती है और रेशनल भी हो सकती है. And what is the value of n here? N means x की power. So what is the value of n here? So from here n equals to 1/2. So it means your given function cos of u is the homogeneous function of degree 1/2. So now if we apply the Euler's theorem here, what is the statement of Euler's theorem? If your function f is homogeneous of degree n, then the value of this term x times del f upon del of x plus y times del f upon del of y equals to nf. This is our statement of Euler's theorem, and we need to find the value of this one. All right. So with the help of the Euler's theorem for the given function cos of u, अब यदि यहाँ पे f की जगह cos of u पुट करते हैं, then we get x times del of cos of u divided by delta x plus y del of cos of u divided by delta y equals to 1/2 cos of u. And what is the derivative of cos of u with respect to x? It is minus sin u. If you differentiate this one with respect to x, then we get minus sin u del u upon del of x. Now again, if you differentiate this with respect to y, then we get minus sin u del u upon del y. Right? So after simplification, take minus sin u common and divide by minus sin u both the side of the given equation. And so after simplification, we get x times del u upon del of x plus y times del u upon del of y equals to minus 1/2 cot of u, which is our required result. यही हमको प्रूव करना था यहाँ पे. All right. So because your given function is a homogeneous function of degree half, so the value of this left hand part is equals to minus 1/2 times cot of u. Right. So this is all about the homogeneous function and Euler's theorems, and we'll continue in the next lecture.